Hello friends, welcome to Chemistry Voice. In this video we are going to study about Pauson-Khand reaction. What's happening actually in Pauson-Khand reaction? An alkyne reacts with alkene and carbon monoxide. The product is cyclopentanone. Okay, look here, alkyne, alkene, carbon monoxide. So there is a carbon-carbon bond formation here between carbon monoxide, alkene and alkyne, you get cyclopentanone. This is a 2 plus 2 plus 1 cycloaddition because there are two carbons in alkyne, two carbons in alkene, one carbon monoxide. So 2 plus 2 plus 1 cycloaddition. Pauson-Khand reaction is an example of 2 plus 2 plus 1 cycloaddition. And the catalyst we use here is dicobalt octacarbonyl. You might have studied about this in your organometallic chemistry. This exists in two isomers. Both are 18 electron species. It is a dimer. If it is a monomer, it can't exist because it is 17 electron species. The dimer is 18 electron species, stable. So there are two isomers. One is bridged, the other one is unbridged. The bridged one is a solid, the other one is liquid. And this is the isomer we use for our Pauson-Khand reaction here. Okay, and when we use this reagent as a catalyst, I mean in catalytic quantity, we have to separately supply carbon monoxide atmosphere. Carbon monoxide gas atmosphere must be maintained separately. Okay, in case we use this in stoichiometric amount, I mean 1 equivalent, 2 equivalent or even more than that, then we don't have to use carbon monoxide atmosphere separately because the reagent itself carries many carbon monoxides as ligands. So that itself is sufficient to provide the carbon monoxide necessary for this reaction. Okay, in that case we don't have to provide carbon monoxide gaseous atmosphere separately. Okay, this is intramolecular Pauson-Khand reaction, alkyne connected with alkene through a carbon network. X may be carbon, nitrogen or oxygen, whatever. Okay, so after the cycloaddition takes place between alkene and carbon monoxide, you get cyclopentanone fused with another ring. Okay, this is intramolecular Pauson-Khand reaction. Okay, how about the regioselectivity of this reaction? Large substituent of alkyne and alkene prefer the adjacent carbon to the carbonyl group. Look here alkyne, it carries a large substituent and this one is a small one. Similarly alkene, it also carries a substituent that is R. Okay, after cycloaddition, the large substituent must go to the carbon adjacent to the carbonyl group. Okay. Similarly, the R from the alkene, that also should go to the adjacent carbon of the carbonyl group. So this is the major isomer. And look at the other. Large substituent went away from the adjacent carbon of carbonyl group. So this is minor isomer. This is not the major one. Similarly, large substituent is at the adjacent carbon of carbonyl group. But here, the R from alkene, it went away. Actually, it is supposed to be here at the adjacent carbon. So it went away. So this is also not the major product. So these are minor isomers. So this one is a major isomer. Look at this one, phenylacetylene and homoallyl thioether. The phenyl group, it comes at the adjacent carbon of carbonyl group. That's fine. And here is also same. So both are okay. Phenyl group at the adjacent carbon of carbonyl group. But this substituent from alkene, here it is okay, but here it is away. Okay, here it is adjacent carbon. So this one is okay. This is a major product and this is minor. Okay, it is supposed to be here. And look at this one. This is intramolecular Pauson-Khand reaction. After the cycloaddition, you get the product like this, cyclopentanone fused with a cyclopentane. Okay, we studied about the regiochemistry of Pauson-Khand reaction. How about the stereochemistry? Actually, the addition of alkene to the alkyne is a syn addition. If we go through the mechanism, you will find a cobalt carbon bond in an intermediate. Okay, there will be an intermediate formed between the alkyne and cobalt complex. In that intermediate, you can find the cobalt carbon bond. With that, the alkene addition takes place. So this addition is a syn addition. Okay, that's the idea. So here the alkene is added to the alkyne and carbonyl group in syn fashion, and that is why you get both the hydrogens at the ring junction below the ring, alpha. Either both should be alpha or both should be beta, because the addition is syn addition. Okay. Now look at this example, intramolecular cycloaddition. Look at this bond at the ring junction. This is above the ring, beta. That means the alkyne will come above the alkene. Now the addition is syn addition. Okay. Alkyne comes above the alkene. So after syn addition, this alkene should go below. That means alpha. So this CC bond from alkene goes below the ring, alpha. Okay, below the ring. That becomes alpha. If this bond goes below, how about this bond? This must come above. Okay, beta. Beta. If we want to gather more information about Pauson-Khand reaction, about the mechanism, examples, applications, and so on, you can refer the books like Clayton Warren and Carruthers, William Carruthers' Organic Synthesis, and so on. Okay. Hope you understand. If you have any queries and comments, please write it in the comment box. We'll meet in the next video with some other interesting topic. Your suggestions and comments are fervently solicited. Wish you all the very best. Thanks for watching.